This data is going back and looking at the COVID cases, but what I wanted to do is to look for trends in the data, but also to start to look for prediction. So this is that first data set. We just have the neighborhoods here at the top, but looking at our table data here, we can look at that time, capturing that data going back to November 16th, and we can look at the recent cases. This is a rolling 21 days of information. So every date reported as an aggregate of 21 days, and we can see that time trend here. We can also look at the heat chart at every neighborhood, again, having that time series looking over time. This is just that first part to look at the data in a chart format, just to see if we can see some visual trends. But I want to start using this to build some forecasting elements. And what we're going to do, and we've talked about this a couple times before, is the SpaceTime Cube analysis. And what we're going to do a little different than other demos we've done with SpaceTime Cube is, because we're already have this linked to geographies, or we're going to link this to the standard geographies. Traditionally, we've gone and done that aggregate by points. We've had point data, but what happens if we already have that in a defined location? We have this data by the neighborhood level, and we want to join this together. So simply, we just put in our inputs, being the source of that information. In this case, it would be let me go back one here to that neighborhood layer. We would be putting in the area that we're looking at, those polygons being the neighborhoods. And we had to create a key for this, but we're just defining the unique identifiers, the neighborhood ID to our table ID here. So there's the tables, and just creating that link between our spatial and our tabular data. Now, this is where we're going to define this. And one of the parts about this data set was there was a report sometimes 3 days a week, sometimes 2, sometimes 1. So we want to look at this from a weekly timestamp, but sometimes the data was not inconsistent in reporting, but if we had a once a week report or twice or 3 times, how do we get that to run? Well, the first thing I want to do is I want to just define the reference time, and we're going to push the system to start back on the November 17th. So we'll go back here, back to November. So that's going to be our defined starting point. We'll actually make it the 16th. And since I don't have time, I'm just going to leave that at date. So we have our start point. But as I mentioned, when we look at what data we want to look at, the sporadic recent, some weeks had 1 reporting, some had 2, some had 3. So we can go back up to this temporal aggregation, and this is going to help us create a nice, smooth space-time cube. So what we'll say is we want to look for the most recent cases, but the statistics are we're going to pick, if it's reported 1, 2, or 3 times in that week, give us the maximum value of that week. And then if we have anything that's missing, we'll start figuring out how we can fill that in. We don't want to drop and say they're zeros, because cases could have happened. So we'll look at the temporal trend of that neighborhood over time and fill in that value. Once we've calculated this, we're going to run in what we create as a .nc analysis. And what this ends up looking like is we can start running things like emerging hotspots. So we can go through and look at where are areas based off of time and trend and area, where are there hot spots, cold spots in the city that we're looking at of what's happening for COVID cases. The other thing we can do is we can look at the data itself and group and cluster that. And one of the things I really found interesting is we can do a time series cluster where we look at which areas had the most cases of COVID or higher risk areas. And as we look at that, and I look at my little chart, what we found is we've grouped this into 3 categories: communities that showed higher risk of case in green, moderate risk, medium risk, low risk. And just from a visualization of the chart, high risk communities start to go up before the low and moderate and semi-moderate or medium risk communities. So we can see where cases start to begin to happen and how they affect other communities that are seeing an increase in COVID cases. But really what the whole point of this little session is my favorite: how do we predict? So we're going to go back into our little tool here at the top. We'll open up our GeoProcess. We'll go into, and there's a several time series forecasting tools, but we're going to look at the forest-based modeling tool. Now I'm just going to pick that NC code we created, that space-time in the first part. Great, we have that. We're going to pick our values, which we've aggregated by the recent cases. Now, how far do we want to forecast? Well, I want to look at 6 weeks out, or I can say 4 weeks. It at least has to be no more than 50% of the forecast data you have. So if I have 10 weeks of information that I'm going to use in my modeling, I can only maximize that at 5. We can define where we'd like to space this out. If we have time windows, so for how many cubes do we want to estimate out, we can put all this in. Now, for those who are familiar with the forest regression, that same tree, we're creating multiple trees of data. It's running multiple scenarios, that machine learning and AI, to come up with a projected value. Now, like a good cooking show, I've already run this. And what we can start to look at is, here's our forecasted model. So it's looking at all the data, and we're only seeing one date stamp here. But if I pick on one area, and I'm going to pick on your area, Chris, Scarborough Centennial area, what we get is a really nice chart on the side here, this table that shows us the trend of the actual data and what we expect to happen on future forecasts within that information. Now, when I collected this data, I collected up to the most recent date of reporting that I had, which was the 28th of March, but I left that off for a reason, because one of the parts we always want to look at is, what is the validity of the data we have, that information. So a quick little final here that I wanted to share was, I put this little Excel spreadsheet together. Hopefully we can get that to open, for every neighborhood. And I looked at what the projected forecast for March 29th would have been based off of the actual of the 28th, because I want to know how accurate we are. So we had that forecast, and we can look at the standard deviation. And really what I found is, when I did a little regression model comparing the two, my R-squared score was very high at 92.5%, or 0.925 correlation. So a very high relationship between the actual and projected values that we had.